Hi guys. So let's talk about what's a graph and how do we make use of it and how do we graph things. So see graph, when you have a function of one variable, you have two variables which are involved. So you have equations in x and y. You have equations in x and y. For example, you have y equals to 2x minus 1, x squared plus y squared equals to 16. These are two separate equations in x and y. Now, the question arises, can these be represented by a curve in a coordinate system? So, first of all, what's a coordinate system? So, when there are two variables involved, the coordinate system would consist of a Cartesian plane. So y equals to fx has such a representation on the Cartesian plane. We call it the rectangular, or it could be called rectangular or the Cartesian plane. A Cartesian plane is basically where you have two lines perpendicular to each other. This line, which is horizontal, is called the x-axis, and the one which is vertical is called the y-axis. So here, as the name suggests, you will put all the x values, and here you will put all the y values. These are your four quadrants. These are your four quadrants. This is your first quadrant, basically, because you're dividing, this is divided into four pieces. So we can say that these are four quadrants. This is the first one, this is the second one, this is the third quadrant, and this is the fourth quadrant. Now, quadrant basically represents the positioning of numbers, positive and negative. So this one is values, this line is for values of x. 1, 2, 3, so on and so forth. The values of x positive here, negative here. When we are just talking about one variable, this line that represents x-axis is also called the real line, right? -4. And here you have y-axis. Y-axis means y values. So you have positive here, 1, 2, 3, and negative here, -1, -2, -3, so on and so forth. Keeps on going on. So this is what is called a coordinate system. Coordinate system. So any equation that you have in x and y could be represented in this coordinate system. Okay. Now, how do you represent points in coordinate system? That is something that you should know. So suppose you have this point PQ in a coordinate system, which is basically x-axis here and y-axis here. This point P, which is represented by P comma Q. Now, P comma Q basically means that this P is x-axis value, this is the y-axis value. So which essentially would mean that if this is the point and I will make perpendicular lines here, which is basically the distance. So basically what essentially is happening, this point P represents that the x-axis value that you have is P. So the distance from origin till here, this is P. This is P. And the y-axis value is Q. So from origin till here, the distance is Q, or the length that you can see is Q. And on the x-axis, it is P. And that is what makes this point P comma Q. This is what is a coordinate system. And that's how a point looks like in a coordinate system. So suppose you have a point, say 1, 1. Suppose you have a point, say 1, 1. So what would that mean? That means that when you will join this, that means that this point is 1 and this point is also 1. So x-axis value, y-axis value, both are basically 1. So x-axis also 1 and y-axis also 1. This point is 1, 1. 1, comma 2 would mean that x-axis is 1, but y-axis value is 2. So this point will become 1, comma 2. And so on and so forth. You know, you can also have minus 1, minus 1. So here if you have minus 1 and here you have 1. So if we would like to take this point into consideration, this would become minus 1. X is minus 1 and y is 1. Similarly, if I take it up, x is 1, x is minus 1 and y is 2. And similarly, you know, you can come to the quadrants below also. In the quadrant below, here x will be negative, y will be negative, both negative, and here x is positive and y is negative. So that is what are your 4 quadrants. Examples. Let's look at some simple examples to understand how you basically graph on any or you know, given any equation, how do you graph on the Cartesian plane? So if I have x equal to 5, it's a constant value 5. X is 5 always. Suppose it is, you know, 1, 2, 3, 4, 5 till here. So x is 5. Y could be anything. So the moment it's written that x is 5, that means x is 5. Y can be anything. Y, anything. So that essentially means that when I will draw this graph, x is 5, that means I'll have, since I can have any value for y, so I'll have a vertical line like this. Y could be negative also. So I'll have a vertical line which is crossing the x-axis at 5 because x is always 5. So a constant function when x is equal to some constant is a vertical line that you can see on the Cartesian plane. Okay, when y is 5, the same logic goes. So what is happening now? This time, y is 5. Y is a fixed value 5. X could be anything. No matter what x is, y is 5. So this would essentially mean that what is happening? You have a horizontal line which is basically telling you that y is always 5, whether x is, you know, plus, minus, anything. But y is always 5. So what kind of points will you have on this line? So let's talk about this vertical line. The points that you will have on this vertical line is, for example, suppose this is 5, 3. So your x-axis value will always be 5 and rest of the values could be anything. So 5, 2, 5, 3. So x-axis will always be 5. Here, y-axis will always be 5. So this will become like, 1, 5. X is anything. This is like 2, 5. This is like minus 1, 5. So y-axis value will be fixed 5. Okay. So that is what is your constant functions. This is what a constant function would mean. X equal to a constant, y equals to a constant. Then you can also think of, x greater than or equal to 0, y greater than or equal to 0. So if x is greater than or equal to 0, y is greater than or equal to 0. What's happening here? So this is your Cartesian plane. This is where y is also 0 and x is also 0. This is called origin. This is your x-axis, x value starting from 0, and this is your y-axis starting here from 0. So this point is 0, 0, where x is also 0 and y is also 0. This is also called the origin. Now we are saying that x values have to be all positive. So x values are positive out here. And y values are also positive. So y values are positive here, only here. So this means that any point that I will pick up here, any point that I will pick up in the first quadrant, any A comma B that I pick in the first quadrant, in this case, x will be greater than or equal to 0, and y value is also greater than or equal to 0. If any point is lying here in the first quadrant, then that means both values, x and y, both are positive. Okay, so x greater than or equal to 0, y greater than or equal to 0 means that the first quadrant, and including, of course, these vertical lines, okay? Vertical and horizontal line, that is x-axis line, because it can be equal to 0 also. When it is strictly greater than 0, the case would be that it is not including the boundaries. Then we can have some more examples here. So suppose x is between 1 and 2 and y is between 3 and 4. So that's possible, right? So suppose this is 1 and this is 2. So for x, this is 1, this is 2. And for y, so suppose this is 1, 2, 3, and this is 4. So this is 3, this is 4. So suppose this is the scenario. So you're saying x is between 1 and 2. That means it's something of this sort. So x is always 1. So x is always between 1 and 2. So x is between 1 and 2 could be represented by these two vertical lines. In between, your x is always between 1 and 2. But we have another restriction for y. The restriction is that y is between 3 and 4. Y is between 3 and 4. Just to make you understand, I'm creating the entire lines. Similarly here for 4. Now, what are we interested in? We're interested in that x is between 1 and 2 and y is between 3 and 4. So we're only interested in this area. This is a square actually. Might not look like that. And when you are creating a graph, then you can actually give the distance of axis according to your space. You can do that. But this essentially, if it's a proper graph constructed, it will be a square, because this gap is supposed to be 1 unit and this gap is also supposed to be 1 unit. So this will be actually a square getting constructed. But this essentially means that any point that you will take here, any a comma b that you pick here, what kind of value A will take, what kind of value B will take. A will always be between 1 and 2 because it's not on boundary, so I'm not even writing equal. And B will satisfy that it's between 3 and 4. So this is what is the area represented by what I gave to you. Okay. Now, graph of equations in two variables. So when you have x and y given in an equation, how do you represent that on a graph? Well, y equals to 2x plus 1. What you will do, you will find out certain points that will be able to give you a skeleton of this graph. So the points I can think of here. Let me take some simple points here. If my graph is 2x plus 1, so let's start with x0. When x is 0, y is 1. When x is minus 1, y is minus 1. When x is 1, y is 3. So I think 3 points are actually in general good enough to create a graph. So let's see the graph. What will it look like? So when x is 0, y is minus 1. So this point essentially will be represented by 0 or 1, 0, 1. Y is 1. When x is 0, y is 1. So that means here, this is the point 0, 1. So this is the point 0, 1. Minus 1. This will be represented minus 1, minus 1, minus 1, minus 1 will be here. So minus 1, minus 1. X and Y both are -1. 1, 3. 1, 3 would be like this. So X is 1, Y is 3. So if you notice what is happening, let's not think of any curve here. No, this is a linear function, so it will not be curvaceous. So you will have a straight line or a linear line like this. A line like this, which is passing through these 3 points and many more points on these lines. We can't, figure out every point. You just need some amount of points so that you can create a graph, a skeleton, which you can, join and figure out, yes, this is what the representation will look like. Now, this was a straight line that you can see. It was a linear relation. I'll talk about linear relation in details in the coming videos. Now, suppose you have a curve like x squared plus y squared equals to 25. So the moment you have put quadratic in consideration, so it won't be linear case. So, you have power, you have degree 2 here. So you will have some curvaceous relation here. So what will be the representation of that? So the representation is simple, just the way we did for linear. The representation will be simple. Your x is equal to some values. Y will be, if I get from here we know that y is plus minus of square root of 25 minus x squared. It's plus minus of square root of 25 minus x squared. So I will start giving values. So when x is 0, y could be plus or minus 5. When x is 0, y could be plus or minus 5. When x is minus 5, you will get 0. When x is minus 3, you will get plus minus 4. Let me take minus 4 first. When you will put the value for x minus 4, you will get plus minus 25 minus 16 will give you 9. So plus minus 3. When you will put minus 3, you will get plus minus 4. When you will put 0, I've already mentioned that you will get plus minus 5. Similarly, you can take 3. For 3 also, you will get plus minus 4. For 4, you will get plus minus 3. For 5, you will get 0. So what are you basically getting here? You're getting here, okay, let's put these points. So this point is 0, 5, 0, minus 5. So x is 0, 0, 5, and 0, minus 5. So that point and this point. Then when x is minus 5, 0, x is 5, then also y is 0. So these are the 2 points. Minus 4, when x is minus 4, y is plus minus 3. So y will be here plus 3, minus 3. Then when it is minus 3, it is minus 4. So somewhere here. 4 and minus 4. Somewhere here. And similarly, the same kind of values you're getting for this side also. So the same kind of values you're getting for this side as well. When it is 3, you get minus 4. When it is 4, you get minus 3. Now, if you look at this, can you see that you are actually fetching something like circular? So yes, of course, this is an equation of a circle, and what you will fetch is actually, you'll be delighted that this will be a circle. I'm not sure if I'll be able to actually construct a circle here, but yes, you can see that, you have a circular shape. How appropriate I can create it. Let me just see. Is something of this sort, something of this sort, something of this sort. And of course, it'll be a proper circle. But since I've taken up big space, so that is why I'm probably not able to construct it at once. So it is a circular shape, as you can see. Okay, so this is how you graph. This is how you create your graphs. Graphs could be simple, graphs could be difficult, but the basic thing will always remain the same about the Cartesian plane and how you plot the points. So always remember, when you're graphing, you're basically plotting the points x comma whatever your function is or the relation is, x comma fx.